Hello, I'm Sandeep Golani from Compute Drive System, Kolkata, India. Today I'll be talking about the chip level repairing and its benefits, merits, demerits of it. And I'm mainly into chip level repairing of desktop motherboard and laptop motherboards and so on. And I'm also imparting training on the same subject. This is a video for those who are into this field. Probably it can be of some use. I'm sharing my views for you all. Now, to start with the motherboard, the very first thing you have to remember is it is the CPU. The main element of a motherboard is the CPU. You can see it on the board. This is the CPU what I am talking about. There are variety types of CPU. They are ranging from 8088 to today's world. What we are using is the Pentium 4. They are dual core, core 2 Duo and quad Duos and also the difference of today's CPU with the older ones are they are more modernized, but as far as the basic architecture is concerned, that remains the same. There is no changes as far as the basic architecture is concerned. That is, even today, if you have a ISA slot in your computer motherboard, in a Pentium 4 motherboard, you can add out your own ISA card, old ISA cards, and you can still execute it. Even in today's motherboard, if you have say like DOS version 1 or 2 or 3 or 4 or whatever it is, which are freely downloadable from the net, you can still execute your machine using DOS. So that's how I say that there is no say like basic difference as far as the older machines and today's machines are concerned. Yes, new items have been added up, the shadow RAM, the MMX technology, the piping technologies and so on. New concepts have been added up and it has been made to work more faster in a lesser span of time and also. So the basic changes which has been made out as far as the CPU is concerned, we can see in the left hand side there is a box called as VRM. The VRM stands for Voltage Regulator Module. Now, in the earlier days, the CPU, we used to set the parameter, that is what is the voltage requirement, because today's CPU they work at a very lower voltage, because if you want to increase the speed of the system, the only answer is by reducing the voltage. Now, today's VRM, they work on an auto procedure. Now let us see what an auto procedure is. The auto procedure is, today the CPU tells to the VRM that what is the voltage requirement. Now depending on the voltage requirement, the VRM generates the voltage for the CPU. The VRM is on board, on the motherboard. Now if I show you a motherboard, you can see this is the VRM section. This is the CPU socket and this is the VRM section. You can find few FETs over there, few inductance over there. So this is the VRM section. Now, to the CPU you can also see there is something called a clock generator. Now what is a clock generator? Clock generator, this entire digital architecture works on the principle of clock. That is, we talk about that, say like my microprocessor is 3 gigahertz or something. So 3 gigahertz is nothing but 3 gigacycles per second. That is the clock speed. That is the thing my microprocessor is processing at the speed of. Every clock is working out or making it do something or the other. Now, below the CPU you can see there is something called as GMCH. This box I am talking about, the GMCH, that is also called as North Bridge. The GMCH stands for Graphics Memory Control Hub. That is, it controls the graphics, that the VGA and the AGPs, and on the right hand side you can see it controls the RAM module. It can be a SD or a DDR or a DDR1, DDR2 or whatever it is. Now, the communication between the CPU and the GMCH is been done by the bus, something called, you can see there is something called as the D bus, a C bus and a A bus. A stands for the address bus, C stands for the control bus and D stands for the data bus. So the communication between the CPU and the GMCH has been done by the address, data and control. Now even in a normal communication language, we always say this parameters, say the address, data and control is always there in our communication language too. Say suppose if I want to say someone, please bring the pen from the table. So pen is nothing but the data, table is nothing but the address, and bring or keep it is nothing but the control, that is to send or receive. So as we require the address, data and control for our communication purpose, exactly the same format we also require it in our computer communication purpose. So this is nothing but the address, data and control. If we come down bit below the GMCH, we can see the ICH. It is called as Interface Control Hub, or we also call it as a South Bridge. All the important IOs, that is especially the USB, the audio AC97, the ROM, the LAN, the ID port, the PCI ports, they all are controlled by my ICH or the Interface Control Hub or the South Bridge. Now, as we come down further, we can see a SIO, or this is also called as LPC. It is also called as LPC. It is called as low pin count IC. That is, it is the least pin countable and intelligent IC as far as the CPU, GMCH and ICH are concerned. So among these four, 1, 2, 3, 4 boxes, this is the least pin count IC. It is called as LPC, or it is also called as SIO, serial input output device. Now, this controls all the lower communicating areas, say like the keyboard, which is a serial communicating device, the mouse again, which is a serial communicating device, the floppy drive again, which is a serial communicating device. There is a game port, it is again a serial communicating device, a parallel port, which is an 8-bit communicating device, again a serial port, which is a single-bit communicating device. So all the lower ends, so from top to the lower, as we go or as we proceed, it is only thing is over here it is working at a higher bit and a higher frequency. As we go down, it is working on a lower bit and lower frequencies. So this is as far as our motherboard architecture is. Now, troubleshooting and repairing is based on this particular aspect or this particular block diagram. That is, say suppose if a problem is there with a USB, never one should touch up somewhere in what do you call the GMCH or the CPU side. If the problem is somewhere there with the keyboard, so no need to control or no need to check out something, your VGA and the RAM and the CPU and the clock generator and so on. You have to concentrate somewhere on the keyboard or maximum to the LPC side. So this block diagram tells you that where to troubleshoot and how to troubleshoot and so on. Now this is my first module on motherboard repairing. I'll come up with the later modules. Thank you. Bye-bye.